Hello dear students, today we are going to discuss our revision of chapter number 4, that is first order reaction, integrated rate constant of zero order reaction and temperature, behavior and collision theory. In this video, our first lecture is based on zero order reaction and half-life time for zero order reaction. So here zero order reaction and half-life time. What do you mean by zero order? The power of concentration is raised to 0. The rate of the reaction is proportional to 0 power of the concentration of the reactants. Means in this example we are supposed to take normal reaction is R tends to P. The rate constant is written as minus dr by dt is equal to K into R. This is most important because zero order reaction है, इसलिए zero power रखना पड़ता है. When you are writing about first order reaction, then this word is replaced by first power of concentration of reactant. We know that R raised to 0 according to the maths rule, R raised to 0 is becomes unity, means 1. So minus dr by dt is equal to K into 1. Okay. Now what should we do here? Reactant portions are on left hand side and this dt we putting on right hand side, and we rearrange the reaction and we will get dr is equal to this minus is on now right hand side minus K into dt. This is our main equation for starting the theory. Okay. Now integrating on both the sides dr we will get only r, because integration r is becomes only r is equal to minus K into dt, that will convert into minus kt plus I. This d was removed and the new digit capital I is introduced. This capital I is known as integration constant. So this is our equation number 1. Now at time t is equal to 0, this concentration of reactant is becomes R0. R0 means initial concentration of reactant. Initial means before the chemical reaction will occur to form a product. So at t is equal to 0, R becomes R0. We are going to put this value of R into equation number 1. So we get the equation is R0 is equal to minus K into this t is equal to 0 is putting over here plus I. So minus K into 0 is 1. So we get R0 is equal to I. Again we are getting the new value which replace I, that is R0. So our equation 1 becomes R is equal to minus K into T plus R0. This is equation number 2. This equation number 2 is very similar, or we can say we are comparing this equation 2 with the straight line equation, जिसको हम बोलते हैं सुरेख समीकरण. When we are comparing this equation to straight line equation, the straight line equation is y is equal to mx plus c. This is the common formula of straight line equation. And if we are plotting the graph of concentration, we get the graph as a straight line, and the slope of that graph is according to minus k, and the intercept is related or is similar to r0. You can see in this graphical value, the graph is r tends to t. We will get this straight line. Over here there is a intercept. So intercept value is r0 and the value of slope is minus k. This is a constant thing according to the y is equal to mx plus c equation. You have to remember that. Now simplifying the equation number 2, our equation number 2 is r is equal to minus k into t plus r0. So we get k is equal to r0 minus r upon t. Okay, I am writing on board very important points only. You have to write the sentences which is included in a theory part when you are writing this theory in your exam or test. I am writing only major steps or important steps or mathematical steps on the board. This equation is known as integrated rate equation for zero order reaction. This is our main equation. Again, this theory is continue for half-life time. Half-life time is represented as T1 half. T1 half is known as half-life time. When we consider our age in years, same as the time of chemicals is represented in a half-life time. So, what do you mean by half-life time? Half-life time means in which the concentration of reactant is reduced to 1/2. Which concentration? The concentration is in a initial period. Suppose in a starting of reaction, the concentration of reactant is similar to 50 molar. Suppose when the concentration is reduced to 25 molar, exactly half of 50 molar, this time is known as T1 half. So in which the concentration of reactant is reduced to 1/2. So our equation is k is equal to r0 minus r by t. Now in this equation we have to change one thing. T is replaced by T1 half and r is according to this definition, initial concentration is becomes half. So r is equal to r0 by 2. So when we are putting these values in equation number 3 or this final equation, we will get k is equal to r0 minus r0 by 2 upon T1 half. This T1 half is on now left hand side. So this k which is going to right hand side. So T1 half is equal to r0 by 2k. Okay. So we can say that the half-life time for zero order reaction is directly proportional to the concentration of reactant and inversely proportional to the rate constant. Again, the half-life time for zero order reaction is directly proportional to concentration of reactant and inversely proportional to rate constant for zero order reaction. So dear students, this is the most important theory according to your board exam as well as in your school exam, which is asked into 4 marks. Okay, so you can write these important points in your notebook, and when we are writing this equation or this theory into exam, you have to add some theoretical points into this theory. So okay, write down these points in your notebook for zero order reaction. Now for a first order reaction and half-life time for first order reaction, this is again the similar question. So you have to change only one thing. in this starting of theory, rate of reaction is directly proportional to the first power of concentration. This word is replaced from above theory. In previous theory, there is a zero power of concentration of reactant R. In this theory, first power of concentration of the R. We are taking one simple equation as before, R to P. So we get the rate minus dr by dt is equal to k into R raised to power of first. This is most important. In previous theory, R raised to 0 and R raised to 0 becomes unity according to the rule of maths. Okay. This equation can also be written as dr by R. This minus is goes on right hand side, so minus k into dt. Now we are going to take integration on both the sides, left as well as right side. So we will get integration of dr by R. We get the values ln R is equal to minus k into t plus this I is again the new parameter is added. This I is known as integration constant. So we will get our equation number 1 for this starting of theory. ln R is equal to minus kt plus I. Now at the starting of this reaction, time is equal to 0. So our concentration of reactant is taken as R0, means initial concentration. So putting these values in equation number 1, we get the equation ln R0 is equal to minus k into 0 plus 1. This is going to be 0. So we will get ln R0 is equal to I. Now this value of I, ln R0, is replaced this I in equation number 1. So our equation number 1 becomes ln R is equal to minus kt plus ln R0. We will get equation number 2. After this equation number 2, this theory becomes slightly different than zero order reaction. Now you have to rearrange this equation number 2. What we do, ln R, this right hand side step ln R0, we have to take this step on left hand side. So we will get ln R upon R0 is equal to minus kt, or you can say k is equal to 1 upon t ln R0 by R. This equation number 2 is again compared with straight line equation as before, y is equal to mx plus c, and when we are going to plot the graph of ln R to t, we get straight line according to this graph, and the value of slope becomes minus k and intercept value is ln R0. So this is most important part. Equation 2 can be written as, equation 2 is over here, ln R is equal to minus kt plus ln R0. After taking antilog, because this steps containing ln means linears, so when we are taking the antilog, the linears will converted into exponential e. R is equal to R0 into e raised to minus kt, and this is our equation number 4. You can give this number according to your preferences. Now equation 3 can be written as, this equation can be written as, after taking logarithm, or you can say simple log. The rule of mathematics is, when we are going to convert linears to log, then we have to multiply by 2.303. So this equation becomes k is equal to 2.303 by t. Now this ln is replaced by log R0 by R. This equation number 5 is the main equation for first order reaction. So you can say that integrated rate constant for first order reaction is represented as K is equal to 2.303 by T log R0 by R. Okay, and if you want to plot graph as log R0 by R to T, listen very carefully. This is one graph which is showing ln R to T. I am talking about log R0 by R to T. At that time you will get the value of slope is according to 2.303 considered. So K upon 2.303, that is the value of second graph. Slope is equal to K upon 2.303. Okay. Now the second part of this theory, T1 half calculation, half lifetime. We know the definition. When the concentration is become exactly half from the initial concentration, that time is known as T1 half. So T is equal to T1 half and R is equal to R0 by 2. When we are putting this value in equation number 5, then we will get K is equal to 2.303 by T is replaced by T1 half log R0 upon R0 by 2. This R0 and R0, both R0s were cancelled out in this equation, and this 2 is coming on upper side. So T1 half is equal to 2.303 by K into log 2. You know the value of log 2, or you can say log 20. The T1 half is equal to 2.303 by K into 0.3010. So you will get the final equation is T1 half is equal to 0.693 by K. Half lifetime for zero order reaction is T1 half is equal to R0 by 2K, and for first order reaction is T1 half is equal to 0.693 by K. In this theory, we can easily give the statement that the half lifetime of a first order reaction is, see, on upper side there is no presence of any type of reactant. Okay, so we can say that this T1 half for first order reaction is independent from the concentration of reactant. Okay, T1 half for first order reaction is independent from the concentration of any reactant and inversely proportional to the rate constant K. Okay, so this is also most important points for first order reaction. You have to add second graph, which I already discussed in this theory. Which graph? Log R0 by R tends to T. You have to show this second graph when you are writing this theory in your exam. Okay, and you have to mention the slope of that second graph is K upon 2.303, and in this half lifetime you have to write the definition of T1 half, and after that you will show this calculation. Okay, write down these easy points of first order reaction. And after these theories, if any student have the difficulty in integration, और आपको ऐसा क्वेश्चन होगा दिमाग में कि ये कैसे आ गया, ये कहाँ से आ गया, बायोलॉजी वाले स्टूडेंट हो गए, उनको इंटीग्रेशन के बारे में थोड़ी दिक्कत होगी, उन लोगों के लिए आई एम गिविंग यू द सिंपल एक्सप्लेनेशन ऑफ आवर फर्स्ट इक्वेशन, which is our integration of equation. So see, this is the explanation of integration in both the theories. First theory is zero order reaction. In that theory you can see this equation in the starting of that R to P. When we are integrating this equation on integration of dt. When we are going to take integration of dr, we get only r minus k into t plus I is equal to constant, which is known as integration constant. This equation is our equation number 1 in this zero order reaction theory, where integration of dr is equal to r and integration of dt is equal to t. These two answers are considered as r is equal to minus kt plus I. In first order reaction, you will notice this first equation dr by r is equal to minus k into dt. When we are going to take integration on both the sides, we will get, see, 1 upon r is on side, integration 1 upon r into dr is equal to minus k integration of dt. So integration of 1 upon r into dr is ln r is equal to minus k into t plus I, and our I is again constant, where integration 1 upon r into dr is equal to ln r and integration of dt is taken as t. Okay, so today's video is specially made for your confusion in a most important theory of chemical kinetics, that is zero order reaction and first order reaction, integrated rate constant equation.